Example 8, revisited, except for in a different fashion. Find the equation of the line that's tangent to y equals complex fraction at the point -1, comma 1. All right, so not only are we finding the derivative, we want to find the equation of the tangent line. Why am I finding the derivative first? Because, remember, that's going to give me the slope everywhere, and then I can just plug -1 in to get the slope specifically at that point, put them both together to write the equation of the tangent line. It should be a piece of cake, but the very first thing that we should do is get rid of the fact that we have a complex fraction here. So we got y equals 3 minus 1 over x plus 5. Now you can't just take this x that's right here and just shove it down to the bottom. No, it has to, you could do that if it was a common factor across the top, but it's not. So you have to multiply by a fancy 1. And that fancy 1 is just the common denominator of an x over x. Do some distribution across the top and rewrite this as a 3x minus 1 over x squared plus 5x. And I would definitely distribute that across the bottom instead of writing this as x times x plus 5, because if you did, you'd have to use the product rule on it to take its derivative, and nobody wants to do that, right? So let's pretend this didn't happen, and I'm going to get rid of it. Now I am going to apply the quotient rule on that. Why do I apply the quotient rule? Because I have a quotient of two functions, and it's not like you can just rewrite this in a very convenient way to avoid the quotient. Sometimes you can, but this one you definitely cannot. All right, so here we go. Probably need some space for this. Y prime is equal to the derivative of the top times the bottom. So the top's derivative is just 3, the bottom x squared plus 5x. Minus the top, 3x minus 1, times the derivative of the bottom, 2x plus 5. All over the denominator squared, x squared plus 5x, and then squared. Remember, just leave that squared. Don't expand it out. It's just asking for misery. Okay, so we can clean up the top, and I would encourage you to do so. If this was a multiple choice type of question, yeah, it is never, ever going to be written like this. If it was free response, that's technically a safe stop. You've done all the calculus. The rest of it's just algebra. So I can distribute the 3 through this. 3x squared plus 15x minus, and then I need to FOIL this thing and then change all the signs. So I'm going to do that in 2 steps just so I can avoid a sign error because I'm prone to it. Okay, so 3x times 2x would make a 6x squared, and then a 15x, and then a negative 2x, and then a negative 5. All right, foiling school. It's like it's Algebra 1 up in here. Imagine giving that problem to an Algebra 1 student. They'd pee. Okay, let's combine our like terms right here in the middle. We've got a positive 13x, and now let's distribute our negative sign through that thing. Calculus, otherwise known as rewriting stuff, lots. All right, so distribute the negative, so negative x, 6x squared, and then a negative 13x, and then a positive 5 over the stuff that I have to write again, squared. And then can we combine some like terms? I think we can, because across the top we've got some x squareds here, so negative 3 of them, and then a positive 2x, okay, and then a plus 5. Can that factor? No, I don't know. I'm not sure I care, especially since if it did factor, chances are, the top and the bottom isn't going to share a common factor for me to be able to cancel out. So I'm good with it like that. All right, so here is the derivative. And now, what did I find the derivative for? So I can plug in negative 1 for x, so I can find the slope at that particular point. So I'm going to find y prime of negative 1. Just plug in a negative 1 everywhere. So negative 1 squared, of course, is positive 1. I'd have a negative 3, a minus 2, and then a plus 5 across the... Is this going to be what I think it's going to be? Negative 1 squared is 1. minus 5 over, it doesn't even matter squared because the top's equal to 0. The bottom's not equal to 0. This is 0. Wow. Are you kidding? All of this work for the fact that the slope there was equal to 0. Okay, so let's write the equation of the tangent line then. Well, think about this. It has a slope of 0, which means it's horizontal. And a horizontal line has an equation of y equals some number here. Y equals b, we'll say. So I can just make it y equals the y coordinate here. So it should be just y equals positive 1. I'm pretty sure positive 1. If that didn't make sense to you, if you don't believe me, of course, you can just write it in, say, point slope form, like this. Y minus 1, which is the y coordinate, is equal to the slope times x minus a negative 1, so plus 1. That cancels out. Add the 1 over. Yes, we get y equals 1. Okay, just, for the sake of being thorough. And then come over here and let's take a look at the graphs of these things because it looks cool. All right. This one is suggesting that we try rewriting that as a single fraction, which we did, and then it also suggests that we pay attention to parentheses when differentiating. Did we do that? I think so. I think I did a pretty good job of paying attention to parentheses. So here is the graph of the original function. We have a vertical asymptote here at 0, and we have another one over here at negative 5. The derivative is also going to have discontinuities there because the denominator stayed the same. And then we also have our tangent line. Now, a couple things here. Notice that over here on this side, the derivative is negative, so we have a bunch of negative slopes on that branch. Okay. On the next branch here, it crosses right here at negative 1. And where it crosses negative 1, hey, isn't that our horizontal tangent line? It's right there. Bam. And then we can see that, oh, it's got a rapid increase. This one is also a rapid increase, and it's always positive. Does it cross right here? It looks like it might. Can I zoom in a little bit? Looks like it might cross right there, which means that there should be another horizontal tangent line right up in there.